Hello everyone. So today I'm going to tell you how you can calculate different components of PZX triangle. So normally in examination, if there is a question on PZX triangle, so they will give two or three components and you need to find other components of that triangle. So we can use two formula for this, one by deriving through Simpson rule and another by using sine and cos formula, which is opposite and adjacent side. So now we will know what is PZX triangle is. So for that we need to know all the things about celestial sphere. So what is celestial sphere? Celestial sphere is just an imaginary sphere of our Earth, in which we have North Pole, South Pole, equator. Zenith is the position of observer on top of observer, and another is the position down below of the observer. So these all are things which are there in celestial sphere. Then there is one's rational horizon, which is the rational horizon of a person. That means the observer. And there is the declination of the body, LHA of the body. Declination is just latitude of a body on the celestial sphere, and local hour angle is the longitude of a body on a celestial sphere. So like we calculate longitude from 0 to 180 degree east and 0 to 180 degree west, but in the case of LHA it is 0 to 360 degree. So if we know the LHA and declination of the body, we can easily know the geographical position of a body on the earth. So by that we know our own position because we know the position line. So now we will see this diagram. So in this diagram we can see the North Pole, South Pole over here, and pole is not elevated, so our observer is on the equator. So Z is the observer, zenith of the observer. This is east, this is west, this is the declination circle. So declination circle means in this circle the body is going to lie, means in 24 hours this is the circle where body will lie. Then this is the rational horizon of the observer. This is equinoctial, this thing, because observer is on the equator. So now we will proceed to next diagram, in which we will show you an elevated pole, and south pole will not see in that case because south pole is below the horizon. So we will check it out our next. So this is our next diagram. So in this you can see the north elevated pole, this one, and this meridian is observer's meridian. This is prime vertical, this line where observer lie. This is the zenith of observer. This is equator. So Q is equator, Z is the observer, so this will become your latitude. And as you can see, the elevated pole, the degree on which this elevated pole is down below the pole, means this geographical pole is same to same as latitude. So our NP will be equal to ZQ. So in this figure you can see NP is equal to ZQ. So I have not shown body over here. So declination of the body I have not shown. So over here we have P and Z. and X is missing. So we will see it in our next diagram. So for this, what I have done, I have just created a circle, and with means you and me will together draw this diagram so that there will be a clarity for this concept. So we will first draw celestial meridian. This is observer's celestial meridian. Now we will draw prime vertical. This is prime vertical. So we have this north, this is south. Now we will use it as elevated pole. So pole is elevated over here. So we will give it a notation P. P. This is P, and in southern hemisphere will not be seen because it is down below the rational horizon of the observer, and this point is Z, that is zenith of the observer, and this is the equator. This NP and ZQ will be equal, so you have to draw accordingly, because I am just drawing a rough diagram, but if you are drawing means as per the measurement, then you need to keep these two equal. So this is east and west. Now we can put our body somewhere here. It can be star, it can be sun, anything. So like we are putting body over here, its declination is X. So just meet this line over here and another line over here. So this angle will become our azimuth. We can write azimuth of the body. This angle is azimuth, and this angle, westerly our angle, is our LHA, means local hour angle of our body, LHA. This angle is LHA. Now, so generally in question they can give latitude, your own latitude. They can give angle this azimuth, or they can say that body is on prime vertical, like over here. Okay, or means they can give anything, so you need to calculate other things. So you can simply calculate by this, you know already Simpson rule. So you can apply Simpson rule if any of the side is 90 degree. You can apply, like if body is on prime vertical, you can easily apply Simpson rule. If it is not on prime vertical, then you can apply cos sine formula. Easily you can do that. So some of the things which you can see from this diagram, like Zx is your zenith distance, and Zx will be equal to 90 minus true altitude. Pz is equal to 90 minus latitude. So sometimes we call Pz as colat. You can easily see from here to here it is 90 degree. So this is your latitude. So 90 minus latitude will be Pz. And Px is your polar distance. Px is your polar distance. And declination is equal to 90 minus px. So whatever be your px, if you subtract it from 90 degree, the declination will come. That means declination is this thing. This thing is your declination. From equator to pole, it's 90 degree. And this px, polar distance, is something. It is given in question, or you have calculated from applying all the formula. So you can easily calculate this thing, declination. So in question, normally they will ask you like they have given you latitude, or they have given you azimuth, so they can ask you to calculate declination, or they can give you amplitude as well, like body is setting and rising. That time this angle, like I will show you what will be your amplitude. This angle, when body is setting and rising, this angle is your amplitude, not this one. This angle is your amplitude. And for finding local hour angle, if you are calculating the local hour angle of a star, so there is one very easy thing you can compute. Like this is the center, this is Greenwich Meridian, this is observer, this is GHA Aries, or you can say is just Aries. You don't need to call it GHA, only Aries. Aries, and this is the body, like star. So you can easily derive the formula for this, like you want to know the LHA, local hour angle. So this is the local hour angle from observer to star is local hour angle, LHA. So LHA of star, LHA of star is equal to, what is LHA of star, is equal to GHA of star, means from Greenwich to the star is the GHA, and this is your longitude. So GHA star plus minus longitude. So if it is westerly, like it is from here to here, then it will be minus. If it is easterly, like this in the diagram, then it will be plus. So just now we have added this one, so we get LHA star. Same thing if we have GHA Aries, like GHA Aries over here. Okay, this is GHA Aries. Longitude we already have, and this thing is SHA star, from Aries to star is the SHA star. So formula will become LHA star is equal to GHA Aries plus SHA star plus minus longitude. So from this formula you can easily find out. So friends, this is how you can solve PZX triangle, and it is very easy. So if you want to know some of the things from navigation or cargo work, so please write comment and don't forget to subscribe my channel and hit the like button as well. Thank you so much.